find the vertex of the absolute value function and then graph it. And so here, we notice that we have the word absolute value function. Now, what does that even mean? And for those of you who have just heard of this word absolute value in mathematics, basically absolute value is when there are straight line brackets where anything inside this bracket has to be equal a positive number. And so if, let's say, if inside the bracket is -9, that would just be equal to 9 because anything inside here is going to be a positive. And if, let's say, inside the number here is 10, the number would just be 10 because it's positive. And so here it says absolute value function. Now, absolute value function, if we take a look at this equation here, we have the straight line brackets, the absolute values. And let me just rewrite this so that it's more clear. We have, if you take a look at this equation here alone, some of you may think that, oh, it looks very similar to the line equation. The line equation, which is y equals 2mx plus b. And some of you may even think that, oh, this is very similar to the vertex form of the quadratic functions, which is y equals to a times x minus h squared plus k. Here, both of you are right. This is a vertex form equation, and it is also based on the line equation. Now, what does that mean? So, let me just first draw a graph. We know that y equals to mx plus b, the normal line for the most common line for y equals to mx plus b is just y equals to x. And what that means basically is let's say this is 1 and this is 2. Let's say this is 1 and this is 2. And what I meant was if this line is equal to y equals to x, basically when x is equal to 1, y is equal to 1, as shown here. It may not be the most accurate, but yeah, basically if the x is equal to 2, the y is also equal to 2, like this. I'm sorry, it's not as accurate, but I hope you understand what I meant. And so this is the y equals to x. And if we take a look at the normal absolute value function, which is just y equals to absolute value for x, we have something like this. And this. And if you notice, these two lines, if you want to call these two lines as two lines, they're both straight lines. At the same time, some of you may wonder that it looks kind of like a parabola, except that it's not curved, it's straight. Well, yeah, both descriptions are right, but it is an absolute value function. And basically, it is just a straight line, and then wherever the vertex is, it will be oppositely flipped in terms of vertically. And so let's say if the vertex is here and we have a line here, then it will be flipped right over here, something like that. And it doesn't always have, the vertex isn't always going to be at 0, 0. It can be anywhere. And absolute value functions, just like quadratic functions, can shift. And what I meant by shifting is transformations. If we take a look at this vertex form of a parabola here, if you remember what we have learned before, we know that we can easily find a vertex just by looking at this equation because we have h and k. Now remember, how do we find the vertex just by looking at this equation? Well, we know that if we know a value of h, we have h, the vertex is going to be h, comma, k. And remember that it is not negative h because even though there is a negative sign here, the negative sign means that it's going towards the right, and so it is positive. Just keep in mind that because I know a lot of people here make mistakes because of the negative sign here. Remember, always when you see a negative sign in front of the h, it is a positive. And if it and if the h is a positive, instead it will be a negative. And so keep in mind of this, and be careful when you try to find the vertex by looking at the vertex form. And so if you look at this equation here, we want to try finding the vertex form. And so how do we find the vertex? Again, like I said before, we just look at the h and k. Well, the h here is 1. The k here is 4. And so the vertex, we have 1, 4. And now let me just draw this graph so that it fits the scale. Let's say this is, let me first delete this first. Okay. Yeah. And so let's say this is 1, this is 2, this is 3, this is 4, this is 1, 2, 3, 4, 5. This is the scale that we're going to use. And we know the vertex is 1, 4, which is right here. Now the next step is to know, the first step is to find the vertex. The second step is to find whether it goes upwards or downwards. And just like the quadratic equations, we have to look at the a. If the a is positive, it's going to be upwards. If the a is negative, it's going to be downwards. And here we have a negative number, and so it will be going downwards. So you can imagine it to be something like this. But how do you know how stretched it is or how wide it is? Well, that we move on to the third step, which is taking a look at the a itself, not the positive or negative sign of a, but the number itself. And so is 1 over 2 smaller or bigger than 1? It is smaller than 1. And if you remember the equation y equals to mx plus b, we know that m is always the slope. Remember, the slope is always rise over run. And we know that the rise is 1 because it's the numerator. And the denominator is 2, and that represents the run. And when we find the rise over run, remember, we said that it's going to be downwards because it's negative. And so you can imagine something like it would be 1. Let me draw a dotted line. We have 1 because the rise is 1 and the run is 2. And you can imagine something like this. 1, 2, 1, 2. And we have our line here. You can also do it the opposite way because we know that it's going to be flipped. Because after we know the vertex is always going to be flipped when we reach that point. And so you can also do this. Let's say this is 1. It would be 1, 2. The run would be 2. And we can do something like this. And there we have it. We already have 3 points. We can keep on going if you want. Let me add one more point here. So now I can do it again. Rise is 1, run is 2. 1, 2, 1, 2. We put our point there, and then we do it again. Rise is 1, run is 2. 1, 2, because it's 1, 2. And we can just, after this, we can erase our points here. And then we can, I'm sorry, this is kind of messy. But after we have erased our points, we can connect the lines together and create the absolute value function. Another way, if you want to accurately do this, is to solve for the y-intercepts and the x-intercept. In this case, you'll notice that the vertex here is kind of separate. It's kind of far from the x-axis. So I won't try to find the x-intercept. Instead, I'll try to find the y-intercept for more accuracy. Remember, when we find the y-intercept, let me rewrite this down here first. Remember, when we find the y-intercept, we learned this many times, even when we're solving for line equations. When we want to find the y-intercept, which is somewhere here, the y-intercept, the x value is always going to be 0. And so we want to solve for y, and we substitute x as 0. Remember, as I said before, anything inside the absolute value has to be a positive. And so here, -1/2 times 0 minus 1 is just -1 plus 4. As I said again, anything inside the absolute value has to be, it always has to be a positive number. Here we have a negative number inside, and so we have to switch that to a positive number. And so it will be -1/2 times 1. It's just going to be 1 because it's always going to be positive. Anything from negative is going to be turned into a positive number. Anything that is positive inside the brackets will also remain positive. And so now we can just use basic algebra to solve for y. So -1/2 times 1 is just going to be -1/2 plus 4. We get 3.5. And we can plot that in. So y is equal to 3.5. What does that mean? Well, the y-intercept is 3.5, which represents 0, x is 0, so 0, 3.5. And we can plot that in our graph, which is right here, which is kind of accurate. This point here is 0, 3.5, and we know that our vertex is 1, 4. And there you have it. This is how you can graph and find the vertex of the absolute value function. I hope this video is helpful. Thank you for watching.